Hi, everybody, and welcome to my IBM Cloud Functions for Terraform uh, presentation. And I will cover in this video how to create an IBM Cloud Functions action using the infrastructure as code Terraform. So I have here my Microsoft Visual Studio Code open, and we're going to be covering today, how to uh, create the IBM Cloud Functions Terraform script to deploy an IBM Cloud Functions action. So we just need a couple of files. So functions.tf, provider.tf. It's going to be how Terraform is going to connect to IBM Cloud. Now here I have a lot of variables for the values that I want: API key, resource group, region, some other extraneous stuff. But I'm using this project for other Terraform scripts as well, hence why I need it. And then I also have a terraform.tf vars, and it contains my actual values. So I'm not going to click on it and reveal that, as that would be a security risk. So what I'm trying to do today is to use Terraform to put my code, my Java code on IBM Cloud Functions service, and it's going to. This is my Java 8 code, and I'm going to be using Terraform to get that code on the IBM Cloud service. Um, uh, okay, so you looked at my code. Let's go to my functions.tf. So to uh, to start, we have the resource definition. This is common to all Terraform, where you define the cloud providers uh, um, uh, resource, and IBM Cloud recognizes IBM Cloud Functions through the name IBM underscore function underscore action. That is the resource. That's the name that how IBM identifies IBM Cloud functions, action, creation, and managing that. So that you can't change. But here we have the specific IBM Cloud functions and the name of the resource that we're managing. Now, this name won't be put on the IBM Cloud Functions website. This will be the name in Terraform how we identify this resource. So it's a Hello Java app that I'm creating, have created, and will be using that. So I named it as Hello Java app, just for my own way of identifying and managing the code. Again, this is serverless code, so I'm going to be putting my Java code on an environment on IBM Cloud without a server, hence serverless. And it will be running the code using the runtimes that are provided by IBM Cloud. And IBM Cloud supports a certain number of runtimes, and there's a listing online. You can view the runtimes by region. Click on US South, and we see the kinds of languages and runtimes that are supported. What kind of code can you run, and as long as it's not deprecated, we see deprecated true, can use it. As long as it's deprecated and it's false for that value, that parameter, as long as it's set to false for that parameter, we can use it. So we have, we have here runtime named Ballerina, Ballerina 0.990. Generally speaking, kind, and then the Ballerina value is what you want to be looking for. So deprecated, you can't use that. But deprecated false, so Node 6, 8, 10, Node.js 6, 8, 10, you can use. Java 8, Go language, So Go language, PHP, Python, uh, we see .NET, Ruby, Swift, and its various versions. So that's what we see here. I'm working with Java, so Java 8 specifically. So we have to here a namespace string, and um, I'm assuming you already have the IBM Cloud CLI installed. If not, you'd want to install that, and you can just search IBM Cloud CLI on Google. It's the first or second result. And once you've installed the IBM Cloud CLI, then you can install the Cloud Functions plugin. Um, and you install it like using this command prompt. Uh, um, and then we do, if you already have a namespace created, you do within Cloud Functions, you can list it to find out what it is that you created earlier. And I created one earlier, so I'll launch my terminal here just to show it. IBM Cloud FN namespace list. It's going to check in the namespace on US South, Stanley IAC function 01, and that's what I inputted here as well. That's why I wrote here as well. So you're gonna either create, and this is a command to create a namespace in Cloud Functions, or you're gonna list the one that you created earlier and use that in the string value here for a resource. Next, we have the name and name string, and this is what we would call the the IBM Cloud function on the IBM Cloud console. So within the IBM Cloud console, what are we going to call it here? And so that's where I chose the name, that I did there. And here we have an example here of all the same code, but from the documentation. I'm just trying to see, just double checking here. So it is, the name, right, is a string. You can name it anything you want, and so on the console, how do I identify the code? It's a hello Java action code, and it's for my identification and for any users that use IBM Cloud Functions on the account. They can see what this specific code is identified and named on the interface, on the console, on the website, IBM Cloud. Then we have an exec block. Here in the exec block, we define the kind of code we're running, and I chose Java 8, and that I covered earlier, the kind here, right? So kind Java 8, you can choose any of the other supported runtimes for your region, and make use of that. And it's important because it will be covered, it will be used on the website by IBM Cloud to identify the type of runtime as well, right? And it will execute it. It will provide support for that runtime, executed on the IBM Cloud Functions service backend, and use that runtime to execute the code. So if it's incompatible, then you're gonna have some errors. And I had that earlier. I didn't properly. When I was creating, I had my hello.java file with my original code, and then when I ran, I had to convert it to a .jar file, so to run Java apps on IBM Cloud Functions, I had to convert it to jar file. So when I set the encoder to UTF-8, and I did it just to hello.java, but I forgot to include the flag -- release 8. So I didn't do this, and it didn't properly run. It didn't properly execute the code. So you'd want to add this little flag here for the specific type of runtime or release of Java in my case, or whatever language that you decide to use. And then from once I did that, I got a class.class file, hello.class file. Then I used the hello.class file to generate a jar file, and which I'm using here to as well. So that takes me to the next section, code. So code, we can use file base 64, or we can use a file. And what I mean by that is, if we look at it here in some of the official documentation examples, we can see that the IBM Cloud Functions, the code is either base 64 in code is what we see, or we can see the code equals file equals. So those are the two different kinds of code, and uh, uh, and and essentially we have base 64 encoded, and also file base 64, and this is depends on the types of file that you're working with, and Terraform will tell you what you will have to use. For jar files, what IBM Cloud wants to do is use file base 64 to encrypt the contents of the jar file, and then send that encrypted content to the IBM Cloud Functions service backend. But some of the other services, you just have to use the file to specify the file itself, like a .js file that I showed in the documentation. So that's something that you will have a response when you try to send the code over, whether it is in the right format, and you can check that using the documentation. And for the specific file, it will tell you if it's something different. And then there's a main string here. This main string has to be equal. In my case, it had to be equal to the Java class name. What I mean by that is, if I open up hello.java, I see my class, public class hello. So my main string had to be equal to this class value. And that is the only way to really execute that. And that's what I did here, main equals hello. And that is necessary to really execute the code, or it won't find it. It won't find that. And it's different if you're using Swift or Go or Python. It will ask for maybe the function name of the function. For Java, it was a class name, and the documentation will get into it, how to prep for different files, Swift or Go or Python. For IBM Cloud Functions, I'll cover, if you visit this link, what exactly and the different formats for the different languages. For the most part, it's going to be the name of the function, the name of the class, but if it's anything different, you can find it through the documentation there. And then I'm going to close the exec block with the curly brace and a bracket, and then end it there, and the whole entire resource with the bracket, another bracket. Now, all the lines with the pound sign and a number symbol, or a number symbol, is comments. So they're not part of the code. Just saying as FYI, if somebody is taking notes and wondering why I have all this green text, or the lines that begin with the pound sign is simply for comments and not part of the code itself. So the code is very short. It's probably made longer by my comments that I've added. So I'm gonna go ahead and everything looks good here, and we're gonna go ahead and apply this code and put it on IBM Cloud. So we can first start with initializing Terraform, and this assumes you have Terraform installed already. and you've done necessary work to get that installed or in. It's very, very simple. You just download the terraform.exe, make sure it's added to the path in Windows. Once you've added to path, make sure you download the IBM Cloud plugin for Terraform, and then create the folder terraform.d, and then add the necessary plugins folder, the Windows AMD64 folder, and then put the file from IBM for Terraform, right? So I assume we've already done all that and covered all that. Next, we're going to do Terraform plan just to make sure this is exactly what we want, right? Sorry for getting off track there. I should have already. We've come so far. Everybody should know how to use Terraform. So that was a little bit of an excursion there, but so we did plan, and we are going to be planning to add one IBM Cloud function, and we see the main and kind, and we see all these numbers and letters and symbols. This is the encrypted base64 contents of our file, the jar file, the name, hello Java action code, the namespace we want this to be put in, and we're going to go ahead and apply that plan. So that looks good. That's exactly what we want. Let's go ahead and apply it. And it's going to be ask us one more time for the sake of making sure we don't make any mistakes. It's going to ask us one more time. Yes, we're absolutely sure. Hit yes. And it's creating it. And it's complete after 3 seconds. Very fast. Apply complete. One resource added. Alright, so let's go ahead and check it out. Refresh the page. And the name that we've been looking for is Hello Java Action Code. That's what we had created it as, one added. Now, you might have seen this earlier because I created it and then I deleted it, and so I refreshed it. So this is so if you saw it before, it was cache. Now this is the one that we just created. If you don't believe me, we can probably pull it up in the logs. Okay, it's gonna take forever, but maybe we can just just get a timestamp. I don't have any way of showing the timestamps, but I can assure you that this was just created, right? And this is what we are going to what we want to run. So it says .jar files, which is what this file can be edited here. Neither can zip files or Docker files, but you can still run them, and that's what we want. So we're gonna first show everything here. We're gonna enable as a web action. Get that, and also invoke it. So we'll do this first. We're gonna go to invoke and give it a couple of seconds, and it's gonna give it maximum 60 seconds, it's running. Give it a couple more minutes, and boom, about 10 seconds in, it says greetings, hello stranger, and it looks like it's done. We can also check it out through here, through JSON, through the web. It's greetings, hello stranger, excellent. And if we go through original code with greetings, hello, and then name, and the name here a stranger. So greetings, hello stranger. Exactly what our code was supposed to do. All great stuff. All great stuff. And that's exactly what we wanted to do. And we are happy to have done that. So we did that. We are happy with the results here. It's running, it's working, and that's exactly what we want. So that's really good news. And so this is IBM Cloud Functions. And there's so much more. We can do packages, which is a bundling together of actions. And there's so much more that you can do using Terraform. But the most important thing is the IBM Cloud Function and creating it, and this is the official documentation. So you may want to bookmark the URL, several URLs, so runtime URLs is also great stuff. And also, if you want to work with other languages, it has information on how to prep those files and really get into the to the gritty of the applications and the code that you want to run. So if, for example, if you want to do .NET, how to go about it, how to install .NET SDK, how to save the files, and how it should be saved. So .NET is .zip. It's going to be .zip files. You won't be able to edit those, but you can certainly run them. So it tells you the different formats. Another great URL to save as well. And so OpenWhisk is what IBM Cloud Functions is built on. It's part of the same. It's part of the serverless architecture that these cloud providers are looking to have. So IBM Cloud is looking to have a serverless architecture, and that's what this code does, and this is what the Terraform script here does. And I'm glad to have created it here for my own use and share how I did it. The official documentation from IBM has all the information on how to add complexities to it and covers all the complexities of it. Again, I'm not an IBM employee, but I am an architect for IBM related work, and so I'm very happy to cover this. Feel free to leave comments if you have any other questions, concerns, and I'm happy to help as best as I can as well. I enjoyed making this, and I wanted to share this tutorial with you. Thanks for watching, and be sure to subscribe, and your encouragement is everything. So thank you again.